Assalamu alaikum. My name is Abdelrhman Walaa, Sprints 3 Team 1 coordinator. Simply, my role was facilitating communication between all the team members. Second, my role in implementation of the project was implementing external interrupt driver, button driver in high layer, and last but not least, working on the app module with the help of my colleague Hossam in order to implement the main flow of the project. Thanks.
Hello, this is Hossam Elwahsh. I'm one of Team 1 members working on the Team of the Core project. I was responsible mainly for the TIO on the drivers, as well as maintaining and organizing the documentation, and also the GitHub repo. You can see in here the repo readme. In specific, like adding the quick links that someone might find useful to get quickly through some parts of our project. And I also participated in debugging and integrating the other modules with my team members whenever I was needed. And for testing, mainly I used the Atmel Microchip Studio emulator to debug and confirm the outputs for my module's functions. And also the test cases can be found in our test protocol sheet, as you can see here. You have the test cases for the DAO, steps to produce, and the expected and actual results, also for the lead driver. Okay, next, for some of our team workshops, we needed something more interactive to debug with instead of using microchip emulator to, for example, make a button press. We need to enter the simulated button press manually by changing the IO port registers from here. And this was cumbersome. So I came up with the idea that we try to find a way to debug our C code directly from Brutus. And after some searching that we have done, we were able to achieve something like this. We have all our C files in Brutus. We also use a built-in compiler in here, and we can directly add breakpoints to the code like this one. And we can now easily run the simulation and the debugger from inside Brutus, so we can really interact with our project from here as pressing the buttons, and also see what's going on from the ESM debugger here, like the values of the global registers and what's happening. Okay, and to keep this short, that was just a quick overview of my role in this project, and my teammates will take it from here. And thank you for listening.
Assalamu alaikum. This is Mahmoud Mowafey from team number 1, the Kermit Team. During this slot, I will present my work in this project. Here we have the team profile, include the tasks that are assigned to all the team members. Here I have one task in the chemical layer, which is thermal drive implementation, and also have another task in the hardware abstraction layer, which is a DC motor drive implementation. Also here we have our testable code file, our test cases for each function are placed, or for each module are placed here. For example, I have listed my test cases for time initialization and thermal delay function, And also for DCM motor, I have placed my motor by more driver. Here we have test my motor initialization and test the chain generation and also set the cycle. Also here my implementation for the timer driver. Here we have timer driver files include the timer configuration of timer initialization, timer 1, timer 0 in normal mode, and also the timer 0 using timer 0 in delay, and creating a delay using the coding and also interrupt for the timer 2. And here we have the timer start and so on. Also for the DSM driver, here we have the DSM driver implementation. Here we have the motor initialization function and also the motor chain generation functions, and also the duty cycle that we are tested in the testable code file. Okay.
Hi, I'm Tarek from Team 1, and my role is mainly documentation part. Here is our layered architecture. We participated in it as a team. Expected time to finish is 2 hours, and actual time it took 2 hours. A state machine diagram. Expected time to finish is 2 hours, and it took 1 hour. Modules description. Expected time to finish is 2 hours, and actual time it took is 1 hour. Drivers documentation. Expected time to finish is 2 hours, and actual time it took 2 hours. Functions flowcharts, I made DCM and button, and it took from me around 2 hours. I'm gonna go through our project documentation. Here is the outline, project introduction, and it contains core components and system requirements, high-level design, and it contains system architecture, modules description, and drivers documentation, low-level design, and it contains MCAL layer, interrupt, and its modules, HAL layer and its modules, and finally, the references we used in our project. Here is the project introduction, and it contains a core components, 4 motors, 1 button start, 1 button for stop, and 4 leads, and system requirements as required in the project. Going through high-level design, this is our layered architecture design, microcontroller layer, MCAL layer, HAL layer, and application layer. Going through the state machine for the system, then modules description, and it's a short description for each module, a DIO module, interrupt module, timer module, and lead module, and button module, DCM motor. And this the system modules design and how modules communicate together. Going through the documentation of the modules, here's the prototypes for functions for each driver. Going to low-level design, and it contains the flowcharts for modules functions, DIO module, and here's the interrupt module functions. Going through lead module functions and DCM module, and this is button module, and this is the references we used in our project. Thank you.
Okay, now we are going to discuss our project test case scenarios, the moving car test case scenarios. We're expecting to have 5 test cases scenarios. First one, to run the project in its normal mode. Second one, running the project while trying to use stop button. Third one, while trying to use start button again. We'll show it. Fourth, we run the project while trying to double press the stop button. And last but not least, we're going to run the project while double pressing the start button. Okay, let's run our first test case scenario. That's it. We're going to start the car to move. We're expecting the default flow of the application. It will move forward long diagonal. After 1 second, it will rotate 90 degrees, then move forward short diagonal, and it will repeat this flow again and again. This is the first test case scenario. Okay. The second one, we run the project while trying to use the stop button. Okay, we start the car, then sudden brake happens again. Start the car, sudden brake happens immediately. Start the car. Okay, let's try in the short diagonal one. Stop. Sudden immediate brake happens. And this is the second test case. Third one, run the project while trying to use the start button again while, okay, this simply will start the car, and during the flow, we'll start again. We expect nothing to happen, okay? And this one, sorry, this one. Okay. Pressing, nothing happens, okay? This is the third one. The fourth test case scenario, to double press the stop button, okay? Double press stop button, start. Double press the stop button, nothing. It takes the first action only, okay? Okay. The fifth, test case scenario, double press the start button. Okay. Start. It only takes the first action and ignores the second one. We repeat it again. Nothing happens. And this is our test case scenarios for moving car project. Thank you. Assalamu alaikum.